Thank you for joining me on this session. Did you have a good time in NDC? It was a great week. The sunshine outside is beautiful, so I think I'm the only person that is preventing you from going outside right now. So let's get started. In this session, I'm going to talk about Dapr, which is a wonderful technology for building distributed applications, and I'm going to show you a lot of code. And we're going to see different building blocks that Dapr has, and not all of them because of time constraints. However, we're going to have a great time analyzing the code that I have here for this session. So first, let's talk about some of the challenges that we face when building distributed applications. The thing about distributed applications is that it's very hard to make them right, because you need to manage a lot of things. There's a lot of moving parts, and it's quite difficult to architect those kind of solutions, right? So for instance, we have a more complex architecture because you don't only have like, a monolith, or maybe you have an isolated application that you have to manage. Actually, in distributed applications, you have a lot of components and a lot of services that are in different servers, maybe clouds as well. And of course, the operation is hard, right? And because of that, we end up focusing more on the infrastructure, right? We, as developers, end up managing those servers. We end up learning some management tools and those things. And of course, the tools themselves are not great, right? And talking about the runtimes, well, there's a lot of runtimes that we can use to build this kind of solutions. However, most of the time we can find that those are limited in language support, and some of them are limited in portability as well. So Dapr is this portable, event-driven runtime for building distributed applications across cloud and the edge. And it's an open source project that stemmed from Microsoft. However, nowadays it's part of the Cloud Native Computing Foundation, and the official site is dapr.io. Actually, that's the place where we can find the complete documentation and the tools and all the things related to this technology, right? So what means that Dapr is part of the Cloud Native Computing Foundation? It means that it's not part of Microsoft anymore. The community is collaborating for creating a lot of building blocks and, creating more components for this platform. Okay, so Dapr, what in the world is Dapr? Dapr is a runtime, okay, and it's a set of building blocks, and it's a set of tools that we can use to build distributed applications, okay? The thing about Dapr is that it's like a buffet. You can choose those components that you can use in your own applications. You don't have to use everything in Dapr, okay? So in this session, I'm going to show you some of the building blocks, but of course there are more, and maybe there are some other building blocks that are being built right now. And of course, as an open source project, is built by the community, and it's platform agnostic. This means that you can build Dapr applications on your Windows or Linux or Mac OS operating system. And this is cool because, of course, I'm going to show you a lot of .NET code. I'm going to use C# and .NET 6. And actually, I built an entire application with microservices to show you those building blocks that I'm going to use in this session. But let's talk about the entire building blocks that we can find in Dapr nowadays. Let's start with this service-to-service communication building block. So if you use this building block, it'll allow you to communicate between services. The thing about that is that, think about it, you need to communicate between service A and service B, okay? You have those two services. How can service A know where in the world is service B, okay? It needs to know the address, it needs to know the port, and what happens if service B has many replicas, okay? There are a lot of service B's instances. What happens then? So you need something like HashiCorp Console as a discovery platform, service discovery platform, to know where in the world is that service that you want to communicate with. Okay, so that's hard. That's hard to solve. You can also use something like maybe a service mesh. Okay, service meshes have the service discoverability functionality in their platforms. Okay, so with Dapper, we can use the service-to-service communication building block to solve that problem, to solve that challenge. We can use it, and Dapper will know exactly where in the world is the service that you want to communicate with, okay? Another one is the state management. In distributed applications, this is very common, and actually in any kind of application, right? Where you need to store something like a key value pair, okay? So with this building block, it's very easy to just invoke its functionality and it'll store the data for you, okay? In the configure component. I'm going to show you that in a minute, okay? So the other one is PubSub. This is a very common design pattern that we use in distributed applications to communicate asynchronously between services, because it's not a great idea to communicate between service A and service B in a direct manner, right? Because you're gonna have a temporal coupling between those services. And for scalability, it's not a great idea to do that, okay? So most of the time, we strive for communicating between services in an asynchronous way. And precisely, this building block allows us to do that. There's another one, the bindings building block, which allows us to create something like the Azure Functions bindings. Have you ever used Azure Functions? You have some classes that react about some of the events that happen in some platforms, okay? So this is very similar to those Azure Functions bindings technologies and components that we can use in that platform. But this allows you to create applications that can react to incoming events, and you can also communicate to external systems, maybe for interoperability, or maybe because you need to execute some kind of webhook outside your application or something like that. And this building block allows you to do that. There's also an actors building block. It seems like we have so many different options nowadays for building applications with the actors model. And this is another one. This comes from the Service Fabric team. I don't know if you have used Service Fabric, but Service Fabric itself has an actor model. And the same team that built the Service Fabric actor model built this building block. Of course, there's another more common actor model framework, such as aka.NET, aka.NET, right? And there's another one named Orleans. However, Dapper includes its own actor model building block for building these kind of applications that allow you to create isolated processes that are running in an isolated fashion, in a single-threaded way, and you can communicate between actors by using messages. Basically, that's the actor model. And there's another one for observability. Observability and monitoring are two of the tasks that we have to perform on a distributed application in order to make it right. Because if you don't have observability, if you don't know what's going on with your services or your applications, you're gonna have a serious problem managing those components and applications. And actually, Dapper includes this building block. And finally, actually, there's another one. Secrets management and configuration, okay? Secrets management allows you to communicate to a secrets platform, such as Azure Key Vault or HashiCorp Vault or what have you, okay? Because you don't want to store your secrets on your app settings.json file. You know, it's not a good idea, right? And this building block allows you to communicate to a specialized secrets platform for storing your secrets, certificates, and any kind of key that you need to store in a secure way. And finally, the configuration building block that allows you to store and manage configuration values for your own applications. Okay, so this is Dapper. And here we can see just one small example about those building blocks. You can think about building blocks such as abstract classes, okay? Building blocks are just like abstract classes, and components are like concrete implementations of those classes, okay? So if we, for that matter, have those building blocks, there are many concrete implementations of each building block for many different vendors and platforms and technologies, okay? For instance, if we can see here in the screen, we can see the state management. Let's say this example, okay? State management, if you use the abstraction, in other words, if you use the state management building block, then you can use so many different concrete implementations of that building block, okay? So that's why I said that building blocks are just like abstract classes, and components are like concrete implementations of that abstract class. So, for example, you can use Azure Cosmos DB, you can use Redis, you can use Firebase, Cassandra, or whatnot, okay? And this is just one small example. And let's talk about the high-level architecture of Dapper. So we have the building blocks, and Dapper, through its runtime, will expose those building blocks, functionalities, and logic, okay? So as far as your programming language supports creating requests through HTTP or gRPC, you're good to go, okay? So you can use any kind of platform and any kind of programming language as soon as you are able to create those requests. And of course, talking about applications, there are many SDKs supported by the community. And actually, the code that I'm going to show you is the .NET SDK for Dapper. But as I said, if your programming language supports creating those kind of requests, you're good to go, okay? And what about the infrastructure? Okay, so we can run Dapper in any kind of cloud. You can even run Dapper on premises. Why? Why do you want to run Dapper in an on-premises application? For modernization purposes, it's a very common scenario nowadays. Actually, I'm doing that in some of the projects that I'm involved with. We're running Dapper as an isolated sidecar on premises for modernizing that old application that we have, okay? Of course, you can use Azure, you can use Google Cloud Platform or whatnot, okay? And I just mentioned a sidecar. The sidecar is a design pattern for distributed applications, and it allows you to include some functionalities that your main application and logic doesn't have. For instance, you can think about the sidecar as the sidecar in the motorcycle. In some old motorcycles, I think it's a common artifact nowadays, the sidecar. But you can see a motorcycle with a sidecar nowadays in the streets. However, it's not that common. What does the sidecar does for the motorcycle? It allows the motorcycle to carry some extra weight, maybe an extra person or pet or package. Okay. However, the main logic, the main functionality is the motorcycle. Okay, so that's how you can think about that design pattern. It's extending, it's complementing the main logic of the application. That's exactly what Dapper does for your application, okay? So as soon as you are able to communicate to the sidecar by using HTTP or gRPC, you will be able to extend the logic of your applications, okay? That's what's happening in your solutions when you use Dapper. Okay, so of course you communicate to the Dapper sidecar by using maybe the SDK of your programming language that you want to use, and then the sidecar will be able to expose those extra functionalities that your application don't have, okay? Cool. So let's talk now about the Dapper anatomy. You can run Dapper in the cloud. You can run Dapper in your own machine. Actually, this is the first hosting option that we have, self-hosted. This option allows you to run the Dapper sidecar as a process. Exactly, that's what I'm going to do in this session, okay? And you can also execute Dapper in a Kubernetes cluster. In this case, Dapper executes as a container in the same pod as your application, okay? So if you have, let's say, 5 pods in your cluster, then you'll have 5 extra Dapper containers injected by the Dapper runtime for you in your cluster, okay? Automatically. And there's a third option for serverless applications, which is the use of Azure Container Apps, which is a new service in Azure. It's in a preview state right now. However, this is a very cool technology because it will allow you to provision and deploy your applications, your microservices in a serverless way. I don't know if you used Service Fabric Mesh in the past. Service Fabric Mesh was a wonderful, wonderful technology and idea. And I think this is the evolution of Service Fabric Mesh, okay? Because you only declare what you want in your application in a YAML file, and Azure Container Apps will take care of the rest. So I think that's pretty cool. And okay, so Dapper is this technology that consists of many different components and tools. The first one is the CLI that I'm going to show you right now. The CLI will allow you to manage the Dapper applications and the Dapper runtime. We have the set of APIs that the Dapper runtime is exposing, the runtime itself, the hosting options that I just mentioned, such as serverless, Kubernetes, self-hosted, The Dapper Sentry is a component that allows you to communicate between services, and it will take care of the encryption when communicating between those two services. The Dapper Placement component will take care of the virtual actors that you might have if you're using the Dapper Actors building block. The injector will take care of injecting those containers in your pods when running Dapper in Kubernetes. And finally, the operator will take care of updating Dapper. Okay, so this is Dapper. As you can hear, there are so many tools and options and SDKs and functionalities. Let's go to the code. Let's get started with this scenario, which is Wisdom Pet Medicine. This is a fictitious company from LinkedIn Learning, okay? Because I recorded a course about Dapper for LinkedIn Learning, that's why I'm using this fictitious company, which is this pet grooming shop and pet hospital, okay? So Wisdom Pet Medicine is this company that, well, you can take your pet and leave it in the clinic or hospital for some procedure or whatnot, okay? So that's the scenario that I'm going to use. Wisdom Pet Medicine strives to blend the best in traditional and alternative medicine in the diagnosis and treatment of companion animals. Okay, so I created this scenario that has 5 or 6, I don't remember exactly, microservices. The main microservices are pet, rescue, hospital, and rescue query. So we're going to use Dapper to implement this solution, okay? Another thing about this is that we're going to implement the PubSub building block to communicate between the pet microservice and the rescue and hospital microservices. But as you can see in the screen, in the diagram, I'm not going to communicate directly from pet to hospital or pet and rescue. I'm going to communicate to the sidecars, okay? The sidecars have the logic and the functionality and all the magic that Dapper includes, okay? So that's what I'm going to do. And then we're going to create a new microservice named Pet Aggregator. In this case, we're going to use the service-to-service communication building block for communicating between the pet aggregator, rescue query, pet and hospital. Then we'll use the state management building block for storing the last result of those queries, okay? We're gonna implement input bindings and output bindings for creating new pets by using Azure storage queues. And the output binding will be used to communicate to Azure storage queues as well for interoperability purposes. And finally, we're going to use the secrets management building block, okay? So let's get started. Here, let me close this. So let me show you the entire application. Of course, this is a public repository that you can download and you can extend. So I have those different microservices running right now. So on the other hand, I have the Windows terminal because I already installed Dapper in this machine for to expedite this process, of course, okay? So if I open up this tab, for instance, and I say Dapper, you can see that I have the Dapper CLI, okay? How did I install the Dapper CLI? Well, if you go to dapr.io and then the Get Started button right here, then you will be able to find the script to install Dapper on your machine, okay? So I already done that here in the Windows option. Of course, I'm using Windows 11. That's why this is the command that I executed, okay? So when you execute that, you're gonna have the Dapper CLI. That's the first step to get started with Dapper. So this is the Dapper CLI, okay? As you can see, there are many options that we can use, such as invoke, such as list, and there are many commands. Of course, I'm not going to show you every single command available. What I'm going to do now is to execute this pet microservice. So I'm going to execute the following command, Dapper, okay? And then I'm going to execute the wrong command. Why? Because this is the way that you're telling Dapper, hey, Dapper, please execute the following command and create an instance of the sidecar, okay? And make sure that my application and the sidecar can communicate between each other. So that's what I'm going to do now. So let's say this application will be the pet microservice. And then I have to tell Dapper, hey, Dapper, the HTTP port that I want you to use is 50,000 or 60,000 or what have you. Okay, so this is the port for the HTTP protocol that Dapper is going to expose to the rest of the world. Okay, and I have to say, okay, then you're going to use this other port that my application is listening in, okay? So for instance, I know that this application will run on port 5000. Make sense? So after you do that, you separate with 2 dashes the concrete command that Dapper will run for you. For instance, .NET run, and then URLs, and then the port that you want to use, in this case, is 5000, just like that, okay? So if I execute this command, the Dapper CLI will create an instance of the sidecar, and then it will execute the command that I passed after those 2 dashes, okay? So right now, the microservice is running, unsurprisingly, okay? However, now my microservice can run and can communicate to the sidecar. Why, you may ask? So, of course, this is very easy. The CLI, there are so few commands that you can use. However, here, I want to show you the following code. So can you read that? All of you? Okay, cool. Thank you. So I'm using the SDK for .NET, okay? I'm not going to use HTTP client or IHTTP factory for creating requests manually. For me, it doesn't make sense to use Dapper in that way, okay? In a real world application, maybe you want to use the SDK, okay? Because otherwise you're gonna have, you have to create those requests manually. And I'm not doing that here. I included this NuGet package reference. This is the reference to the Dapper SDK, okay? So this is the thing that I did. And also you have to configure Dapper in your middleware, okay? Of course, I'm using ASP.NET Core as my platform for building microservices, okay? So that's why you need to configure your middleware. And this is the line of code that allows you to do that, line of code number 15 in this case, okay? So that's why if I run this command, I will be able to communicate from my application to the sidecar, okay? Okay, cool. So let's get started by doing the following. Those microservices have their own databases, okay? So let me delete this and this and this other two as well. I already have those databases because I was doing some tests. However, I'm going to run all of those microservices and let them create the databases for me. And I already have this script, as you can see, so you don't watch me, you don't need to watch me typing all the time those commands, okay? So run, okay, run, and then run. So pet, rescue, hospital, rescue query, okay? Oh, run, I'm not in the correct place, or am I? It looks like I'm not in the correct place. So let's see, Dapper, run. Anyways, rescue query is not needed right now. That's why I don't have this script. So I'm running pet, rescue, and hospital, okay? What I'm doing now is this. Let me go back here. I'm doing this, okay? So I already created an instance of the sidecar for each microservice. That's why I have those scripts, right? So you don't have to watch me typing all the time. And what happens? What's the message broker? That's the first question that comes to my mind right now. What's going on here? Because, okay, let's see the code if we can find anything here. So in the pet application service class, I have number 38, as you can see. Dapper client, publish event. This is the way that you use the SDK. You use those methods that are common between all of those building blocks, okay? So for instance, I know I will use Redis right now, and I'm going to show you why, okay? However, you don't have to worry about Redis in this application. That's the magic and beauty of Dapper, because you're only programming against a common interface, okay? So that's why I just say, okay, Dapper client dot publish event async, and this is going to use the configure component that Dapper detected, okay? So why? Let me go back here to the Windows terminal, and I'm going to show you some important thing. After you install Dapper, you will have some containers running on your machine, okay? You don't need Docker. However, if you have Docker, Dapper will use Docker, okay? So when I installed Dapper, some of those Docker images were downloaded for me. And now they're running as containers, okay? So Dapper will use those containers automatically. Why? Okay, so next topic that I want to show you right now. After you install Dapper, you will have this .dapper folder, in your home directory, okay? And here, you're going to find the default components that Dapper uses. So if I go here to the components folder, I will find those two files, PubSub and state store. So those two files are the configuration for the PubSub building block and the state management building block. Okay, so if I show you the pubsub.yaml file, you can see that this will use Redis, which is localhost 6379. That's precisely Redis running on my Docker container, okay? That's the default behavior of Dapper, okay? So in other words, when I send a message, Redis will take care of those messages for me, okay? So this is running. I'm going to show you right now this Swagger web page that comes from the PET API. So, of course, those microservices are running, and now I have the databases created for me, okay? However, I don't have any kind of data, and that's expected, okay? So, for instance, I don't have any kind of pets right now, okay? So if I go back here and I click on try out, and then the name of the pet, and then the breed, say my dog is a beagle, a tree-color beagle, 10 years old, and a dog, okay? If I execute this, well, unsurprisingly, this will return to 100, and I can go back here to show you that I have the dog record right here, okay? So nothing fancy, this is just Entity Framework core running. And now I want to show you what happens with this, because I want to communicate to the hospital microservice and rescue microservice. To the hospital microservice, when there's a pet that you need to transfer to the hospital, okay? And I'm going to communicate to the rescue microservice when I want to flag a pet for adoption, okay? Let's say that the company rescued this little dog or this little puppy in the street, so they're going to create the pet record in the pet microservice, and then they're going to flag that pet for adoption, okay? So if I go back here, let's flag the pet for adoption and then try it out and then execute. Okay, so again, unsurprisingly, this will run, and now I have the data of that dog here in the rescued animals metadata, okay? Why? Because when you're using microservices, it's okay to repeat data, okay? You have to strive for isolation and autonomy of those microservices. So if you have a single database for all your microservices, then maybe you will have a tough time managing that, okay? So that's why those microservices have their own database, okay? And we can talk about eventual consistency, and we can talk about why this is happening, but that's a topic related to the microservice topic and principles. And I'm not going to do that in this session, okay? Okay, cool. So what happened? Well, the rescue microservice was able to receive the message because if we see here, let's say, adopter application microservice, blah, blah, blah. This is not it. This is the other, this one. Let me find it. No, this is not it. Let me show you. Right here, okay? Line 25, okay? So this is the way, again, I'm using the SDK, okay? This is the way that you decorate your methods when you want those methods to be the publishers of those events that are happening by using the PubSub building block. Just one line of code, okay? 25, I'm just telling, hey, I'm subscribed to the PubSub component, okay? And I want to listen to messages in the pet flag for adoption topic, okay? That's what's happening here with a single line of code, okay? So again, if I go back here, I want to show you this. Oh, sorry, this. Okay, this is the name that I'm technically using in my code to identify which component I want to use in the code, okay? So that's why in my string, it says PubSub. The name could be Batman or Spider-Man, okay? It doesn't matter. What matters is that you use the technical name that you are using in your concrete components, okay? So another interesting thing here is that if I execute Redis commander and I navigate to this place, you can see that I have those topics already created for me, okay? So that's another thing that Dapper does for me. I didn't create those topics, okay? Pet flag for adoption and pet transfer to hospital were created for me, okay? So that's interesting. Cool. So let me go back here because I want to, in addition to flagging the pet for adoption, I want to transfer the pet to the hospital, okay? So try it out, execute. And again, I won't show you the code because it's the same. I'm using publish event and I'm using the topic attribute, okay? So again, I want to show you the data. Because in this fictitious company, this is important. That's why I'm going to show you the patient's metadata, okay? So I have Johnny, the Beagle dog record right here. Okay, cool. So now, let's move on. What happens when you want to communicate between services? That's the first building block that I described, actually, the service-to-service communication building block. So let me change branches. And before I do that, let me show you a couple of other commands that I'm going to use in this session. Dapper list will show all the different applications or services that are running by Dapper, okay? So that's a nice way to see all your different applications that are running in that particular machine, okay? Another one is Dapper Dashboard. Okay, so Dapper Dashboard will run the Dapper Dashboard, unsurprisingly, in this 8080 port, and here you can visually see those running applications, okay? It's just like the Dapper list command, however, you have this nice web page, and you can see more information about those applications, and you can stop those applications, and actually you can go here and watch those different components that were loaded and detected by Dapper, okay? So that's a nice way to understand what's going on in the application, okay? So in this case, I'm using the PubSub and state store components. Okay, so now I'm going to switch gears here. Let me, let's do this. Repos, and then stop all. I'm executing Dapper stop, so I don't have to Control-C each tab, okay? And now, let's do this. Git branch. Okay, so git checkout 02, service-to-service communication. And now let's run the application again. So here in Visual Studio, no, okay. Now I have this other pet aggregator microservice, okay? Just like in the diagram. So the pet aggregator microservice will communicate to those other three microservices, okay? How? Okay. The first thing, remember, you have to use the Dapr SDK. Then you have to configure the middleware. And then you use the methods. In this case, I have this pet aggregator controller class. And as you can see, now I'm running invoke method async. So in this case, it's a generic method, which is pretty cool because this realization will execute by me automatically, okay? And you have to specify the HTTP method that you want to execute and the name of the application and then the name of the endpoint, okay? So for instance, the pet microservice has a pet query endpoint and rescue query as well, and the hospital microservice as well. So let me go back here and now run pet API. This must be running, so Dapper run app ID pet. It looks like this is enough. And I don't have the scripts right now. I don't know why. Anyways, let me do this super fast, okay? Anyways, Dapper run, and the application name will be rescue, and the HTTP Dapper HTTP port will be 50,001, and the app port will be this one, .NET run URLs, and then something like this. I don't want to type everything again. So something is wrong with this branch, okay? So bear with me, guys, please. Okay, so app ID, hospital, and this will be 50,002, and this other port. And finally, I have to tell .NET Run to run this other microservice in this port. Okay, so something's wrong here. Failed to bind to address. What's going on? So it looks like something is missing here. So it looks like there's an application that is running that I can't see now. Dapper run, rescue, Dapper HTTP port, IAPR port. So it looks fine to me. App ID, Dapper HTTP port. What's going on here? Should I it's running where? Here? Now, actually, this is running just the Azure function, not the entire application. Yeah, I have this instance because the hospital microservice was created by using the event sourcing pattern, and the Azure function is projecting the data that comes from Azure Cosmos DB, where the hospital microservice is storing the events. And that's why. That's the reason why. You have to read the code. It's a pretty great implementation about the event sourcing pattern. However, something's going on here. Let me try another thing, okay? So I'm going to stop all of those different .NET processes. I was playing with this in the hotel 1 hour ago, so maybe I changed something or I'm not sure. Okay, so no .NET processes, okay? So again, this should be running. This should be running again. Come on. No, it's not working. I don't have any other application running. What's that? Yeah, maybe I can try to do that. However, I don't think I will have the time. Only when I'm sorry about that. Hold on. So this is. Uh, Let me check out the pops up branch and notepad run API rescue port. Everything's running. Okay. Check out. Git checkout 02. I'm suspicious about my terminal. Yeah, it's running. So my syntax was incorrect or something. The colon. Oh, thank you. Oh my God, you have eagle eyes. It was so small and you detect that. Thank you very much. For the, yeah, of course. I didn't see that. Thank you very much. And something's going on with the hospital microservice, the Dapper HTTP port. Before the port, .NET Run URLs. You ah I'm sorry. Plus colon. Oh my God. Thank you very much for telling me that. I wasn't paying attention to that. And just because I didn't have my script files, because that's precisely what I wanted to avoid, to type everything, because there are so many different moving parts here. And okay, let me try again. Hospital. Yeah, I know, but I'm control C this. I'm trying to stop this. Let me try with this other one. Rescue query. Okay. God. Do I have the script here? Let me go to the Windows clipboard. Okay. Oh God. Okay. Dapr on rescue query. Free. .NET run free. This will run plus colon. Yes. Anyways, thank you very much for telling me that. And lastly, the pet aggregator. I'm going to use this port, 55,000. Anyways, let me go back here and try to understand if we can execute the pet query, the pet aggregator microservice. Pet is running, rescue is running, hospital is running, and rescue query is running, okay? And also pet aggregator, okay? Cool. So if I go back here to the Swagger page and then I navigate to the, let's say, Swagger page of the pet aggregator microservice, then I will be able to execute this. However, Dapper is, I'm sorry, this is not working. Pet query on app ID pet. So it's missing the correct app ID. Anyways, moving on, let me show you a couple of building blocks and before we finalize this session. So that works. My script is wrong. My typing is completely incorrect because I missed those scripts. Okay, so let's talk about the bindings. Again, let me go back here and I'm going to stop all the different applications, okay? Stop all, okay? Because I want to change branches to the state branch. And here I want to show you the implementation of how you can use the state management building block for storing the state, okay? So for instance, here in the pet aggregator microservice, there is a small change here because the query itself, now it's here in the query pets method. And here I'm using the get state entry async method that comes from the SDK. So I'm storing the state for 30 seconds. That's what I'm doing here. I'm retrieving the data from those microservices that the service communication building block is not allowing me to do that because I have some mistakes in my script, okay? However, when I receive the results, I store those different records and the data by 30 seconds, okay? For 30 seconds. After that, after 30 seconds have passed, I execute again the query pets method. So it's just a small logic here for showing the state management. And let's try this. I hope I have here, yeah, I have the script. Precisely the one that I was missing. Run. Can you see that? It was easier. Run, and run, okay? So it looks like all of those are running again. And if I go back to the browser and I refresh this, I will be able to try it out, execute. Pet query. Something is wrong with my pet query. Is pet query running? Resident, no. That's what's happening here. Yeah, something is wrong about my own code and with this application and the script that I'm running. However, I wanted to show you the code. And finally, I want to show you the bindings code. And so you can take a look at this. The first binding is in the pet API microservice because here, when you create you can create a new pet by using those bindings, okay? So if I go here, let me show you pet controller. Where is it? The name of this here, pet input binding. This is the way that you configure an input binding with Dapper. You just say, hey, I want to use this name of the component. Why? If I go here again and I show you the components folder, here's the component for this particular binding, okay? So you can see this name here, pet input binding. That's the name that I have for that binding, and that's precisely what I'm using in the code. And that's for the input. And now for the output, let's go here to the, where is it? Integration controllers, integration events controller. Here, pet transfer to hospital. Where is it? Where is it? So I want to transfer the pet. Again. Oh my God. Is this in this place? I just can't find this. So let me show you the name of the input binding. Pet output binding. Let me search for this. And it's right here, hospital application service. And this is the way how you communicate to an output binding. Very easy stuff. You have to say the name of the output binding and the name of the command that you want to execute, and then the payload. And this is communicating to Azure storage queues. So let me try one more time. Run C. Is this because I'm not running the components? Yeah, some scripts are missing. Run C. Okay, this is running. Let me go back here to the Azure portal, and in the queues, pet queue, I want to create a new message. So for instance, I want to create a pet by using an external system. That's what I'm trying to do here. So if I go here and copy this and then go here, okay? And then I have to change the ID because otherwise I'm gonna have some problems with the primary key. Let's say other breed pitbull. Let's say again beagle, because I don't remember and I don't trust how I'm typing right now. Maybe pitbull has 2 T's or 2 L's. I don't remember. Yeah, and that's validated, okay, because it's using domain-driven design, and there are some restrictions that are being validated. Okay, species dog. Okay, so what's going on here? Okay, so okay. And we should have the pet. Oh. Is this running? Breed is not valid. That's interesting. And I told you that, right? I don't trust my typing. Breed beagle. Other be Oh! Oh my God. It's so tough to type and watch the screen at the same time. Yeah. Yeah, that's right. I, yeah, there it is. Wow. Anyways, the code is there. The code is working. What's not working are my fingers. Okay. I'm going to put this repo in my public GitHub account. And there was this secrets management scenario missing. However, this is very long. That's why I'm not going to show you that. And of course, the session is over. And thank you very much for bearing with me, guys. Dapper is excellent. Use it. The Wisdom Pet Medicine scenario works perfectly. You have to have a lot of different moving parts, okay? And that's normal because this is a microservice application and it's not an e-commerce application where you have the order and product, and that's a very popular scenario. However, you can use microservices in any kind of vertical, in any kind of market, okay? That's why I created this. And thank you very much for coming. Enjoy the rest of the weekend and see you next time, okay?